Hello everyone. In this video, I would like to show how can we set up the Ethernet communication between the IFM Vision Sensor and the Siemens S7-1200 or S7-1500 PLC. From this website, we can find out the IFM Vision Sensor information. The common used two-level vision sensor we can find from the IFM website. One is this Contour pattern match sensor, O2D 200 series, and this piezo counter block tool sensor basically for checking the part present, which is a O2V 100 series. So those two series are common used vision sensor from IFM, and the price of those two series sensor, they are affordable. As I found, they are very easy to handle. So in this test, I will use this Contour pattern match vision sensor, which is a O2D 200 series. And to find out the detailed information, we can click this link and then find out the detail type you are going to use. For example, in my case, I'm going to use this type, O2D 220. And once you go to this website, then scroll down and find out this downloads. And then we can download the manual and the Siemens example program, Rockwell example program. And regarding the Rockwell, as I found, because this download file, it has an EDS file. So as we know, to build up the Ethernet IP communication, if you have an EDS file, and if you are using the Allen Bradley compact logics or control logics, it's very easy. And the reason to show the Siemens communication, that's because actually in this camera, it doesn't have a Profinet communication. It doesn't come with a Profinet communication. So to implement the Ethernet communication between the Siemens controller and this camera, O2D 200 series or O2V 100 series, basically we are using the TCP IP communication. And fortunately, from S7-1200 or S7-1500 Siemens PLC, a built-in TCP IP client or server function. Also, this website provides this example program, and this example program includes a sample program. That sample program allows S7-1200 or 1500 PLC as a TCP IP client and communicate with this IFM Vision Sensor. So let me show how can we implement that. So firstly, you need to log in and download this link. It has an example program. Also, it has a manual. That manual is very useful. This is a configuration software for this vision sensor. And keep in mind, this O2D 200 vision sensor, it needs this E2D 200 software. Okay, and this software, it doesn't need any license. It's just an EXE. You do not need to install this software. You just run that execution file. It's very easy to operate. Once we download the software, we can direct double click and run the software. So we can go to the IP address and you can click this find sensor to find out the vision sensor. And the default IP address of this IFM vision sensor is 192.168.0.49. And once you find out the IP address of this sensor, you can click this connect. So we can jump into this page and then we can go through some settings here. Firstly, go to the global sensor setting and we can go through some setting here. Okay, firstly, we can type in the IP address, set the new IP address if you need. In my case, my IP address of this sensor is 0.24. Okay, and keep in mind, to implement this TCP IP communication between the IFM Vision Sensor and the Siemens PLC, we need to select this TCP IP. If you are going to use a Rockwell controller, you can select this Ethernet IP. Then you will use EDS file to set up the communication. But if our PLC is a Siemens PLC, we need to select the TCP IP. Keep in mind here, this sensor doesn't come with the Profinet, so that is not typical Siemens Profinet communication. So we need to use the TCP IP client and the server communication. So that's why here we need to select the protocol. So as I found, we can select this protocol version 1, this version. And this output format, this is the ASIC format. Okay. Basically, we leave this default here. And then let's go to set up the vision. So firstly, let's go to the program 1 or application 1. So we can click new. And then we can click the next. We start to build up this model definition. In this program, I will set up two models here. So one is this. Firstly, I will create this. Click create model and then click the next. So we can set up the detail parameters for this model. We can set up the tolerance and the minimum match. Okay, click the next. And then it will ask us to set up the one model name. So this model name basically is a tool to match this pattern or match this contour. Okay. Click OK. This is IFM1. If you have a multiple pattern to check, so you can click new to set up the second one. So let's set up the second one. Okay, I'm gonna select this time. For example, I will select this area. Click create mode. Click next. Okay. And click the next. Set up this is a model 2. Okay, we have a 2 mode here. And if we need to check both of them need to pass. So we can click this all model. The detailed description for this, find out the manual of IFM Vision Sensor. Okay, and then click next. So here define the output. So we need to select the TCP IP. And at here we can click the change setting. So firstly, so here we need to configure if we need the result output, we click yes. So we need to output the result. If you need the model detail output, for example, the pattern match % value, we can click on. So this data frame will include all those information. So the TCP data frame will include those items we clicked with on. Okay, and the string will include the start and stop, and this string will be the TCP/IP communication, this whole string data frame. Okay. If we are using the digital I/O output, so you can configure, for example, select the model 1 or model 2 or all of the model detected to select for the digital output. And in this test, we will use this TCP/IP. And then we click OK and click the next. Trigger configuration, keep in mind here, so we need to select this process interface. Okay, and here we can click this test trigger. So we need to select this process interface and then click the next. This allows the TCP to trigger this vision sensor. Okay, and here, this is the last step. So if we click this next direct, it will ask you, we must test this first. So to test this, we can click this test application to on. And then click this release trigger. So to do a rough test. So from this test, we can see the current application or program that is A1. In this A1, we have two models here. And the model 1, the matching level is 100%. The model 2, matching level is 100% here. So we can find out the detail parameter and the values here. Okay, so once we finish this one test, we can click off. And click the next. So this step is very important. Here we need to click the yes to save the application. So those applications will be saved inside the vision sensor. Okay, we finish the first one. So here to demonstrate the program switch after, I'm gonna quickly set up the second one to A2. And then I will slightly change this A2 program. For example, let me go to this A2 to slightly change this IFM1, this model. Okay, click the edit. Model definition, go to M1, click Edit. I will change this frame to this area. So once we switch the program, the application, we can see this camera is working on different program. Okay, let me click Next to quickly finish this setting. Next, TCP IP, double check. Okay, we select this. Click Yes. So the trigger comes from the process interface. Yes. Click On. So let's do a release trigger, and we can see its pattern is here, A2. Okay. Save. And now in this IFM Vision Sensor, we have two applications here. And keep in mind, we need to select this process interface to TCP IP. And to monitor the vision, to monitor the live image, we can select this monitor. And now this vision is waiting for the trigger. Till now, we basically finished the configuration in this IFM. Then let's shift to the TIA portal side. And keep in mind, you need to log in into this IFM website and download this example. Once we download, you can find out the 3 examples here. It depends on which kind of controller you are using. If you are using the 300 or 400 controller, you can use this folder. Okay, and this is a step 7 project. And if you are using the TIA portal and the new version S7-1200 or 1500 controller, so we will use this example, TCP version 3. This is the latest version. And to find out detailed procedure, you can use this. So this menu. And this menu only has 15 pages, which is very useful, especially at the end of this menu, it shows the detailed status code. So once you have something wrong, you can find out the detailed status code to troubleshoot the communication. So for example, here it shows all the status code here. In case your communication got something wrong, you can find out the code and find out the description here to troubleshoot. Okay, in this example program, it programmed by TI Portal version 14. And in this case, I will use a newer version, that is the TI Portal version 15.1, this TI Portal project. And I will use TI Portal version 15.1 to open this example. Okay. TI Portal version 15.1. Then click the Open Project. Okay, let me browse the TI Portal project. Go to this S7-1200 TCP version 3.1. Okay, open this project. And because I'm using version 15.1 to open this old version project, it will upgrade this project to version 15.1. Click Open. It was version 14. Okay, it will ask me if I need to upgrade. Click this Upgrade. And now we can see its version is 15.1. If we go to this project folder, we can see it leaves this original version folder and create another folder that is a version 15.1. So this old version is still here. So it set up this new folder. This is the new project here. Okay, now let's go to look at this project. So firstly, let's go to the device configuration. And this example program, it used 1212 DC this controller. And in this test, I'm using 1211, another controller. So let me right click and click this change device. We will change the new device according to your actual controller. Okay. And in this case, I'm using this DC relay and this. And here, keep in mind, to implement this TCP/IP communication between the IFM Vision Sensor and the Siemens 1200 and 1500 controller. So we need to use the new firmware version. Keep in mind this. If we scroll down and find out the page 4, so here the 1200 PLC its firmware should be greater or equal to version 4.1, and 1500 PLC its firmware should be greater or equal to version 1.8. So if you just purchase some new controller to implement this communication, their firmware should be okay. The latest firmware for the 1200 controller, their latest firmware is version 4.4. Okay, so let's go back to the TI portal. So this is my controller. I'm using this version 4.3. Okay, click OK. And after this, we can see this controller already shipped to my controller. And let's hit the save and compile this project. Okay. And now let's double click, go to the hardware, and then let me set the IP address according to my controller. My controller IP address is 201. Okay. From hardware portion, we need to replace this example controller according to your actual controller, and then set the new IP address. And from programming wise, let's go to the OB1. It demonstrates if this controller is communicating with two IFM vision sensors, which is very useful because sometimes if you do P2P, one-to-one communication, it will be fine. But sometimes if you try to connect the next one controller set up two connection, it will have some problem. The key reason that's because this controller is communicating using TCP IP. So this PLC is running as a TCP IP client. To set up the TCP IP client connection, for different connection, this local port is not the same. So for example, for this sensor 1 is using 2000, this port number. And for this second connection is using this 2001. This connection number should not be the same. And how many sensors this controller can communicate? So we can go to the device communication and find out this connection resources here. And this open user communication indicate how many connections this controller can support. Okay, for this case, my controller can set up 8 connections, TCP IP connections with other devices. And in this case, I will use this O2D sensor 1. Okay, here the IP address we need to change. This IP address that comes from the vision sensor IP address. If we quickly recall, if we click this application, go back, and in this test, my vision sensor is IP address is 0.24, and this TCP IP port number is 50010 here. So let's go to the TI portal side. So in this case, I need to change this IP address to 192.168.0.24. So keep in mind, this IP address is the target IP address, the vision sensor IP address, and this port must match with your configuration. So from vision side, that port is 50010 here. Now we finish this configuration and the programming change, so which is very easy. Okay, let me compile and download this program. Okay, so once we download, let's hit this monitor online. Okay, to set up this TCP IP handshake and communication, we need to turn on this connection to true, always true. We need to keep this connection, this signal to on. We will turn on this trigger, and then let's watch this busy and down signal. Trigger. And we can see the output status. The busy shows true, and the actual application number shows 0. They are not correct. So let me check. Okay, so that because the setting application here, this has a typo problem, I think, that comes from this original example. Here should be the application setting here. So this is the one glitch from this original example. And here it should be the app number 1. Okay. And let's see. Okay, its address is MW2. So M address that come from the S7-1200 PLC internal memory. So this is the app number 1. This is the setting address. This is a feedback. Okay, let's download. And now let's turn on this connect. This connect signal need to be on always. So we can see now the busy turn off. Looks everything good. So let's set the application number to 1 first. And then turn on this change application, this command to on. Okay, now it changed to application 1, which is correct. And once this application reached to 1, don't forget turn this change application command to off. So currently it shows correct. And now let's turn on this trigger and watch this busy and done signal. Turn on, so we can see busy turn on in a short moment, and then this done signal turn on. Once it's done signal turn on, that means this trigger cycle complete, and error shows false. Okay, and this received length, it shows 77. That means we received the data. And let me turn off this trigger signal, and in the meantime, watch this done signal. So once I turn off this trigger signal, this done also turn off. This is the entire trigger sequence. If we record this Siemens and IFM Vision Sensor connection, this manual, 15 pages. So as a page 12, it shows this sequence here, this timing chart. So the correct trigger sequence, we need to turn on this trigger signal till we get this done. So the busy will turn on, and once this sensor finishes the processing, so the done signal will turn on. After the PLC receives this done, so we can shut down the trigger, and in the meantime, this done signal will also turn off. This is the entire correct trigger sequence. And if your trigger signal cannot last on enough, so we will get a false. We will get an error here. Keep in mind, your trigger signal cannot be turned off until you get a done signal. Okay? And now we triggered this camera. Let's shift to the vision side and see the actual trigger results. So as we can see, this vision sensor is running application 1. And these two models all pass. From this output, we can now find the pass or fail the results. That's because the pass and the reject results come from this response, this data buffer. And this data buffer comes from this DB3, O2D underscore data, we can see here. And if we double click this DB3, and it prepared two buffers for two sensors. So we can expand this, and here's an online monitor. And then we can check the current status. And according to this frame, if we quickly record the setting from the vision side. So if we go back to the application, and let's go to this application. So click the A1, click this edit, go to the process interface. So click this TCP and click this change settings. So we can see our entire string is start from this start, this keyword, and stop using this stop keywords. So if we shift back to this string here, so it start using the start and following four charts, that is a pass, PASS. That means this application it got passed. And the following values shows a matching level. At the end of the string is using stop. That means this string gets the end. Okay. Another way to monitor this result, we can use this watch and false tables. From this example, it also prepares this watch list for us. Okay, we can double click this watch list. And here's the online. And here we can also use this modify value to trigger or set the application number. Okay. And from here, it monitor the DB. This O2D underscore data here. And this come from the response underscore sensor 1. Okay. So this array is start from 0. And the pass, this 4 charts that start from the number 5, this index number, is using 4 charts here. PASS, that means this result shows pass. Okay, now if I'm going to use one sticker to hide one pattern, and let's trigger it again. So, okay, I'm going to hide one pattern. And now let's shift to this vision sensor to monitor again. And let's re-trigger it. Okay, let's turn on this trigger signal. Click this modify. And don't forget, turn this off after the trigger. Okay, we can see this result from number 5 index, it shows FAIL fail. We can see because I'm using this sticker hide this pattern. So the model 1, it got a pass, but the model 2 got a fail. And then let's test the program shift. Okay, so now, firstly, let's set 2 to this application number, this MW2. And then let's turn on this change application, this command. And then let's turn on this change application at here, this trigger command. Let's turn it on. So we can set on. So we can set 1 to this bool. Then we will trigger this change application. Watch this timing. So basically after 1 or 2 seconds, the camera will shift to the new application number. Number is 2. Okay, let's turn this trigger off. And now let's trigger this camera again. Trigger. So it's running the application 2, and the results got failed because I'm still using that sticker now. So if we shift to the vision side, so the application 2 is checking this area and this area. So this area got a pass. It's running application 2. And this sticker is here. So the second model got a fail. And now I'm going to take this sticker off. Okay, let's re-trigger this application 2. Okay, at here, turn this off and trigger it again. Okay, turn this trigger off. And now let's shift to the vision side. And now it shows pass as this application 2. This model 1 got a pass, model 2 all got a pass. So we can see the result, it shows pass. Okay, this is the trigger and the results and the program change. And next thing someone will ask, how can we get one bool results shows pass or fail? That idea is we need to sort this PASS, this word out to compare and then give a bool signal. When this bool signal turn on, that means this inspection got a pass. If it's got off, that means this inspection got a fail. So let me show how can we program this. Okay, firstly, let's go offline. And then let's add a new data block. Okay, select this data block. I will use this default number 4. And we will name it data block underscore IFM underscore results. So firstly, I will declare one string. So I will name it str result data underscore sensor 1. And this data type, that is a string. And then I will declare one bool signal. Then I will declare this bool signal, sensor inspection pass. Keep in mind, this is a bool. Okay? So after this, let's flow this window. And then let's go to this program, so OB1. And then under this network 1, let's add a new network. Click, insert network. Okay, so this is the result of sensor 1. And then let's go to the right side, find out the instruction. Go to the external instructions. Find out the string plus char. And let's select this, chars to string. Convert array of char to characters string. Okay, drag it out. Okay, we can hit the F1, go to find the help. So as we can see, the key idea of this instruction, it can convert the array of the char to the string. So it has two key parameters. One is where it has two key parameters. One is this, that is the start. Where is the start? We need to sort the string out. And one is the length. How long, how many chars, we need to sort this out. Okay, so let's go back. So firstly, this object, so we will sort this result from this O2D underscore data response underscore sensor 1. So we will copy this. And then where it can be the start, let's go to find this monitor. So as we can see, this array from 0, and this pass, this result start at 5, this index number. So we will start at 5, and this length equal to 4, pass or fail, the length of 4. Okay, so at here, it start at 5, and this length, we will sort 4 chars here. And here, that is the result. This result, that is one string. So we declare that string. So we declared this string. So we will use this string. So click this variable and drag to this output. Okay. And now let's compare. So use the compare instruction. CMP equal. So the idea is we will compare this result to check if this result equal to pass. Once it's equal to pass, we turn on that result. That result comes from this DB, inspection pass. We can drag to this output. Okay, we finished this program. Okay, let's download. The previous result, it shows pass, and now this pass bool, it shows on. That means this inspection got passed. Okay, now let's demonstrate again. Let's shift the program to number 1. So firstly, I need to set this application to number 1. Watch here. So once I set, we set number 1. Okay, and then let's trigger this program switch. Okay, we turn on. So after 2 seconds, so this program changed to 1. It shifted correctly. Okay, let's turn this off. And now this vision sensor is running application 1. Let's trigger it. Trigger. Okay, it got a new result. It shows pass. And here the result shows a pass. And the result bool shows on. Okay, and this vision shows pass here. And now if I put one sticker here to hide this pattern, let's see. Okay, let's trigger it again. Okay, so turn off this trigger, turn off this trigger, and turn on this trigger again. Okay, turn this off. So we can see the result shows fail, F-A-I-L, and because the result shows fail is not equal to pass, so this bool results pass turns off. And from this vision sensor, we can see, because I'm using this sticker, so the model 1 pass, but the model 2 fail. So the entire test of results shows failed. Alright, this is a demonstration of the TCP communication between the IFM Vision Sensor and the Siemens S7-1200 or S7-1500 PLC. And keep in mind, the controller firmware for the 1200 PLC, it should be greater or equal to version 4.1, and 1500 PLC its version should be version 1.8. That's because behind this IFB1, the internal program is using some instructions. That instructions only compatible with those firmware CPUs. And keep in mind, to sort this result out, we also program one network additional program here to compare this pass results to get one bool pass or fail results. Okay, that is for today. Thank you for watching. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.